Getting hardware into orbit is one of the most lucrative industries on the planet. Right now, there is an intense global rush to build and launch commercial satellites, advanced weather monitors, and communication payloads into the sky. For decades, India's presence in this arena was entirely driven by ISRO, the state-run space agency, which built a formidable reputation for cost-effective planetary exploration. But delivering thousands of commercial payloads to low Earth orbit requires a completely different operational speed. It demands massive pools of private capital and rapid iterative engineering that a government monopoly simply isn't designed to provide on its own. To capture a meaningful share of this booming orbital delivery market, the Indian government had to step back and allow private companies to build their own rockets. That regulatory opening arrived with the Indian Space Policy 2023, which officially authorized non-government entities to undertake end-to-end space activities. This government graphic illustrates the transition. In 2014, the country had exactly one recognized private space startup. Following policy reforms, that number spiked. By 2026, the ecosystem surged to include over 400 space startups operating in the private sector. At the very front of this new pack is Skyroot Aerospace, led by founders Pawan Kumar Chandana and Bharath Dhaka. Having hundreds of startups registered on paper is a strong economic indicator, but the ecosystem remains entirely theoretical until one of those companies can actually build and launch orbital-class hardware. Skyroot's answer to that challenge is the Vikram-1, a 22-meter-tall orbital launch vehicle developed entirely in-house. Reading the technical specifications, the Vikram-1's primary economic utility is its capacity. The vehicle is engineered to carry payloads of up to 350 kilograms directly into low Earth orbit. Skyroot integrated several indigenous engineering choices. The structure is fully carbon composite, featuring one of the longest monolithic rocket stages in the industry. Further down, we see the rocket's orbital adjustment module is powered by a 100% 3D printed liquid engine. The design is then rounded out with an advanced ultra-low shock pneumatic separation system, built to ensure payloads deploy safely once they reach zero gravity. Swapping traditional metal alloys for composites and machining for 3D printing cuts manufacturing time and reduces overall vehicle weight. That directly translates to cheaper, more efficient orbital deliveries for commercial clients. All of this engineering was put to the test on July 18, 2026, at the Satish Dhawan Space Center in Sriharikota. Validating years of private research and development, Mission Agmans successfully cleared the pad. When Vikram-1 took flight, it marked the exact moment an Indian private company launched an orbital vehicle from domestic soil. The launch immediately verified that indigenously developed propulsion, avionics, telemetry, and flight control systems could perform accurately under the intense physical stress of atmospheric exit. With those systems proven, Vikram-1 acts as a scalable foundation for a domestic commercial launch industry. India's space economy currently sits at an $8.4 billion valuation. Based on this new private infrastructure, it is projected to grow to between $40 and $44 billion by 2033. Following that trajectory, the government targets $100 billion by 2040. By dismantling a decades-old monopoly and proving they can build the hardware to compete, the Indian private sector has positioned the country as a highly competitive manufacturer in the global orbital economy.